All right, in this video, we're just going to go through a few more examples of the chain rule. You're going to see that this is a very repetitive process, even though we're dealing with different functions at the moment. So let's get stuck into it. First one is we're going to differentiate y equals 16 over 3x squared plus 1. Now, we've seen previously that it tends to be better. Most of our rules for differentiation work better without these fractions, at least with what we've learned so far. So I'm actually going to take that expression on the bottom, 3x squared plus 1, and we're going to move it to the top of the expression there and just give it a power of -1. And this will let us use our chain rule. Remember that the chain rule we said in words, it's differentiate inside the bracket times differentiate outside the bracket. So dy dx is going to be equal to, the derivative of what's inside the bracket here is 6x, right? Multiply by the power, subtract 1 from the power. Of course, the plus 1 disappears, so to speak. It's not magic, but it disappears when we differentiate. So derivative inside the bracket is 6x times, now we're going to differentiate outside the bracket. So we're just thinking of this as like 16 blob to the power of -1. And if you had to differentiate that, you'd times by the power. So -1 times 16. You'd keep the chunk there, all right, which is always what happens in the chain rule. What's in the bracket kind of stays as it is. And we subtract 1 from the power, so we get -2. And if we tidied that up a little bit, well, let's see, we've got 6x times -1 times 16. Okay, 6 times 16. Well, 3 times 16 is 48, so 6 times 16 must be 96. So -96x, the bracket, 3x squared plus 1 to the power of -2. And if we went with the idea that we'll write our answer in the same form as the question, well, we could rewrite this as -96x over 3x squared plus 1 to the power of +2. Okay, so that would be our rule for dy dx after applying the chain rule. Okay, next one, similar idea. We're going to have to do some manipulating at the start. We're differentiating the cube root of x squared plus 2x. So let's think of this original as y equals x squared plus 2x. Remember, a cube root is really a power of a third. And again, we can apply the chain rule now by differentiating the inside of the bracket. So dy dx will equal 2x plus 2. That's our derivative inside, times by, so we're going to use a bracket here. Differentiating outside the bracket, which is multiply by the power and subtract 1 from the power. And 1/3 take away 1 would give us -2/3. Okay. So again, we can do some extra simplifying here. We've got a third times, this bracket to the power of 1 times this bracket to the power of -2/3. We can move that bracket to the bottom of a fraction to give it a positive power. So 2x plus 2 can stay on top. There's also a 3 on the bottom here because we've got 1/3 already. So 3 times x squared plus 2x to the power of 2/3. And if we want to write it again in the form of how the question was written, well, we can say that this is, actually don't need that bracket on top, 2x plus 2 over 3 times the cube root of x squared plus 2x all to the power of 2. Okay, and that would be our final answer for, or the result of differentiating the cube root of x squared plus 2x with respect to x. Okay, so just more and more practice with using the chain rule here. And remember that if anything looks kind of a little bit complicated, you want to be absolutely sure, you can go back to the method of using the u substitution. And at the start of this one, we could have said, all right, this looks a bit messy. I'm going to make sure I get it right. I'm going to let u equal x squared plus 2x and then work out dy du and du dx separately and then bring them back together. You're still going to get the same result. The shortcut method obviously gets you there a little bit quicker. But you use what you think is most comfortable and most accurate. All right, we might try to power through a couple more questions just in this one video. These are examples of exam questions, and sometimes it's nice to see the sorts of things that will come up on exams. This one here is from an exam 1, and we're just being asked to differentiate the square root of 4 minus x, which looks pretty straightforward, but you still have to be a little bit careful with this one. What I would probably do is firstly rewrite this as the square root as a power of a half, because we know that that's going to be helpful. But I'm also going to rewrite 4 minus x as negative x plus 4. Because that reminds me, or makes it really clear to me, that the derivative of what's inside the bracket, the derivative of negative x plus 4 is negative 1. And I think that a common mistake in this question would have been to just treat this like the derivative is positive 1. So, with that said, let's work out our answer. So, chain rule, differentiate inside the bracket. So the derivative of what's inside the bracket is negative 1 times differentiate outside the bracket. So multiply by the power, subtract 1 from the power. Okay, so there's our derivative, and our final job is really just to tidy that up a little bit. It's a 1 mark question, so we're not really getting marks for working here. We just got to make sure we've got our answer correct. We would have, so, well, we're probably okay to leave this as a fractional power, but let's stick with this idea of rewriting the answer in the form of the question. So power of negative a half is going to move it to the bottom. So let's see, negative 1 stays on top. On the bottom, we're going to have 2 from the half. Negative x plus 4 to the power of positive a half. And that will equal, by tidying things up, negative 1 over 2 times the square root of negative x plus 4. And of course, you could write that as 4 minus x in the bracket as well, but that's completely fine. So there's our derivative. Again, 1 mark. I would say a lot of the time with 1 mark questions, you might not want to put too much working, but this is one where it's definitely worth the working steps just to make sure you've got it correct. Because if you try to do it all in your head and just go straight to the answer, there's a chance you're going to make an error. Okay, question 15 is a multiple choice question from an exam 2. So we could use our calculator here, but it's actually one where the calculator is not going to be all that helpful. We're being asked to find the derivative of, because it says for y equals this, dy dx is equal to, so the derivative of the square root of 1 minus f of x. So f of x is just given as a general function here. So if y equals the square root of 1 minus f of x, well, really, we could say that y is equal to 1 minus f of x to the power of a half, okay? And again, this form, even though it looks a bit funny, this form we can apply the chain rule to. We can say that dy dx equals, now the derivative of what's inside the bracket, derivative of 1 is 0, but the derivative of negative f of x would be negative f dash of x, so there's our derivative of the inside, times by differentiating the outside of the bracket gives you a half times 1 minus f of x to the power of negative a half when we subtract 1 from the power. Okay, so, well, let's see. All of the options are written with square roots and or fractions. So let's try to get our answer to look somewhat like that form, and we'll hopefully be able to see which of them corresponds to the right, or which option corresponds to our one. And so we have negative f dash of x times, okay, so let's go negative f dash of x, let's keep that on top. Let's move the negative powered part to the bottom. We've also got a 2 on the bottom because that's being multiplied by half, so 2 times 1 minus f of x to the power of positive a half, which will be 2 times the square root of 1 minus f of x. All right, and let's see if we can find an option that matches that one. We've got, running through them, A, not quite, doesn't have the negative f dash of x. B, C, no. D, no. E, that's looking promising. Yep, same as us. Okay, so option E is our correct option here, negative f dash of x over 2 root 1 minus f of x. So the question looks a little bit unusual, but try not to be thrown off when you see questions that sort of have, you know, general notation in them, or extra unknowns like those questions that have a M or a K or an A, B, and C in the rule. Often the rules that you know how to use are going to be the rules that answer these complicated looking questions as well. So don't be thrown off by them, read them carefully, and sometimes just putting down your first line of working then leads you to the second line of working, and then you know what you're doing and you're off to the races. So good luck with the rest of your questions, and I hope these examples help you understand the chain rule a little bit better.